Welcome to Spring LIB.
Hi everyone, so what we have here is a block B of negligible size and mass M. And we also have a bigger block AC that has an acceleration A0 and it is pushing block B. What we're asked to solve for is the distance that block B travels as a function of time. We know that the block is starting from rest when s equals 0, t equals 0. We know that the initial condition is that the velocity is equal to 0. The concepts that we're going to be using to solve this problem is Newton's second law, so F equals ma, but also the concepts of relative velocity and relative acceleration. So let's go ahead and get started. What we can do is first use Newton's second law. So we can say that the net force in the x direction is going to be equal to mass times the acceleration in the x direction. So what we can do is we can say that the acceleration at B is going to be equal to the acceleration of AC plus AB given AC. And what this actually translates to is basically AC is equal to A0, because that's given to us in the problem, plus AB given AC. We know that 0 is equal to m acceleration of B sine phi. What we can do is then say that AB sine phi is equal to 0. We know that AB sine phi is equal to negative A0 sine theta plus AB given AC. Now what we can do is go ahead and plug this back in to our original equation here. And what we get is that 0 is equal to m times negative A0 sine theta plus AB given AC. Therefore, what we can do is we can isolate AB given AC, and this gives us that this is equal to A0 sine theta. Now we can just directly integrate this quantity because we know that acceleration is equal to velocity over time. So we can say that this is dVB given AC over dt, which is equal to A0 sine theta. So therefore we can say that dVB given AC is equal to A0 sine theta dt, integrating both sides from 0 to VB AC and from 0 to t gives us that VB given AC is equal to A0 sine theta times t. So this is one part of our final answer. We're also asked to solve for s as a function of t. So we can again just take the next integral or a subsequent integral of this equation shown here, because we know that VBAC is just equal to s over dt, so ds dt. So we can see that ds dt is equal to A0 sine theta t. ds is equal to A0 sine theta t dt. Integrating both sides gives us that s is just equal to 1/2 A0 sine theta t squared. And that's our final answer.